Today we'll take an example on how to calculate the RMS and average value of the various waveforms. So I'll be teaching you some tricks that you will need to solve these questions within seconds. So please, this is Atega Tech Academy. Kindly remember to like, share, and subscribe. We also have a Telegram channel with the same name, Atega Tech Academy. You can just search for the name on Telegram and join so that you can get access to these slides and the solutions of these manuals. So please kindly take note of that. Okay, find the RMS value and the average value of the waveform below. So we realize that this is a triangular wave, and I've already explained how to find the formulas we use to find the triangular waves in a separate video, so you can go and watch that if you don't understand the formulas I'm using here. So let's just solve this within seconds. To realize that this waveform starts from here, this is a triangular wave. The duration of this waveform is 4. But where does another triangle starts again? It starts here. So meaning the period of this waveform, the total period before another triangle will start again is 6. But the duration of the triangular waveform is 4. So we need to find the area of the triangle. So finding the area of the triangle, the base is the duration of the triangle is 4, from 0 to 4. Then the height or the amplitude is 3. So it's simply half base times the height. So doing that, so our half base times height is half 4 times 10, which is 20 volts. So when we get our 20 volts, we now find our average value. So to find the average value, we use this formula, which is average value is area under the waveform over the period. The period, why, you might ask, why is it 6? It's 6 because the total period of the waveform here, it started from here. Where do we see another waveform starting? It's 6. So that is why the total period of the waveform is 6. So it's now 20 divided by 6, where we come and get our 3.33 volts. So this is how we calculate the average and RMS value of a distance, a triangular waveform. To calculate the RMS value, we need to find the energy of the signal. So the energy of this signal. So energy of the signal is equals to the 3 square, the height square, times the duration of the period, which is from this 0 to this 4. So let's say if there was a value here, I subtract, so it will be the 4 minus 0. So 4 minus 0 is 4. So it becomes 3 square times 4 all over 3 is already in the formula. So we get 12. So energy of the signal is 12. So we now square it, the RMS value will now be the square root of the energy of the signal divided by the period. So it will now be our 12 here divided by our total period, 6, which is equals to the square root of 2. So we get our VRMS as 1.41 volts. So this is how we calculate the RMS value of a triangular waveform. Problem 2 says we should find the value, the average value and the RMS value of the waveform below. But let us look at something. You realize that there are a lot of waveforms here. Realize that from here, this is a sawtooth. And so let us name this one A. This is another waveform. This is B. This is a rectangular waveform. And this is C. This is also a sawtooth. Let us look at the waveforms different. Where the waveform starts at 2, the triangular waveform starts at 2, then it ends as 4. Then the rectangular waveform starts at 4 and it ends as 8. So if we want to find the duration of the rectangular waveform, it becomes our 8 here minus 4. And we also want to find the duration of this, our sawtooth waveform, it becomes 4 minus 2. And for this waveform in the upper side, their amplitude is 10. And this one is in the negative side, the negative direction. So here we also find the duration, which is 10 minus 8, which gives us the 2 as the base, and the amplitude here is minus 10. So we see that the waveform, the total period of this waveform here is 12, because 12, it will start at 12 again. At 12 we see that the whole thing is repeating again. So at 12 the whole thing is repeating. So if you decide to pick, so we can also name here as A and
here as B, and here as C. So it's the same, it's just repeating. So we'll just consider one waveform. So we'll consider the first one, A, this AB. We'll consider the first one and leave the second one. So considering the first one, let us calculate, we have to calculate the area of all the waveforms. Then we add them up in order to find the average value. So to do that, calculating the area of waveform A, which is the sawtooth. So the sawtooth, we said the area is half base, the formula is half base times height. So it becomes half times 4 minus 2 is 2 times the amplitude, which is 10. So we get our 10 volts. Then we're calculating area B, which is the rectangular wave, or some people call it the square wave. Calculating the area of this, it becomes our length times our breadth, and our length is 8 minus 4, which gives us 4, and the breadth, that's the height, the peak, is 10. So it will be 10 times 4, which gives us 40 volts. And calculating the area of this sawtooth, you see that this one and this one is the same, but it's just that the amplitude is in the negative direction. So we can just also use our formula, half base times our height multiplied by our amplitude here becomes minus 10 because it's in the opposite direction, and the amplitude here is also minus 10, so it just becomes minus 10. Then we get 10 volts. So to now find the total area of this waveform, it becomes you add A, B, and C, area A, B, and C to get our total. So the average area, average value is area under the waveform over the period. So the area under the waveform now becomes 10 plus 40 minus 10 all over 10, because you see this is where the total waveform ends. It started at 2 and is ending here, all over 10. So we do that, we get 4. So we get our average value as 4. Then what do we now need to do? We need to now calculate the energy of each signal. So calculating the energy of each signal, we realize that this signal and this signal, they are the same, it's just that they are in the negative direction. So whatever value you get for A is same as C, but it will be minus. So energy of the half sawtooth or half triangle, it becomes, this is the formula we use, it becomes this is for A, h squared times the duration of A. So the duration of A will be 4 minus 2 all over 3 plus the rectangular wave, which is h squared times the tau, which is the duration, which is 8 minus 4 time plus this one, the C, h squared times tau all over 3. Then we divide it by the total period. What is the total period? It's from here to here. So the total period here would be that. Then we just substitute our values. So you see, it's our 10 squared times the 2. How did I get the 2? The 2 is 4 minus this 2. Then the next waveform, calculating the energy, is 10 squared times 4. So here is the height square times 8 minus 4, which gives us 4, plus here is the same as this, but you see that it's minus, the amplitude is minus, so we just negate it and divide it by the total period. Doing that calculation, we get our total answer as 2 root 10, and the 2 root 10 is 6.3246 volts. So this is how we calculate the RMS value and average value of the various waveforms. You see, this question, they just kept a lot of waveforms, just trying to confuse you, but it's really simple. You can just calculate this within seconds. So thank you very much. Kindly like, share, and subscribe for more videos. Thank you for watching up to this point. If these videos have been helpful, kindly like, share, and comment. Please, we have a Telegram channel. Please take your time. It's the same name, Atega Tech Academy. Just check. We'll share the slides and everything on Telegram for you to take your time and go through and really understand. I'm signing out. Take good care of yourself. Bye.